Okay, lesson 1, Introduction to Exponential Functions. So graphing calculator obviously is going to be super helpful in this unit, mandatory in this unit, but we're going to do some stuff by hand first before we get into the tech, just to kind of hopefully show you what we're working with. So let's graph this function, y equals 2 with an exponent x. So if our exponent is 3, it would be y is equal to 2 cubed, and that gives us a value of 8. And then we get y equals 2 squared, which gives us a value of 4. And then y equals 2 with an exponent 1, which is just 2. And then we get y is 2 with an exponent 0. Now, I just was teaching my grade 9s about this, but anything with an exponent of 0 is 1. And then it gets a little trickier. So y is equal to 2 with an exponent negative 1. And negative exponents, if you recall from grade 10 or 11, is going to be the same as 1 over the same base, but with a positive exponent. So that's going to just simplify to 1/2. And then it follows that 2 to the negative 2 is the same as y 1 over 2 positive 2, which gives us 1 over 4. And then lastly, y is 2 negative 3 gives us the same value as 1 over 2 cubed, which is 1 over 8. So let's go ahead and graph this stuff. So 3, 8, 2, 3, 1, 2, 3. So up there is 3, 8, and 2, 4 is going to be there, and 1, 2, 0, 1, negative 1/2, negative 2 1/4, negative 3 1/8, and we're doing something like this. All right, so domain is x. Well, x is an element of the real number system. The range is going to be greater than 0. And y-er, the y-intercept. The y-intercept is where it crosses the y-axis, and that is at point 0, 1. And does it touch the x-intercept? It does not. The x-axis. So there is no x-intercept. And the asymptote, there is a horizontal asymptote at y equals 0. So the horizontal axis, y equals 0. Because the line is never going to intercept or cross the y-axis, it's an asymptote. Let's graph y equals 3x and y equals 5x on the same grid. So if you have technology, you can use it. If you do not, you need to pause the video and do a little chart and come up with some values. So my hint for you is to do some x values and pick some y values. Okay? So probably, x values of like 3, 2, 1, 0, negative 1, negative 2, and then you've got two functions. So 3 exponent x and 5 exponent x. And what you'll see is that 3x, you're going to have a point at 2 and 2, 9. All right, and then you're going to have a point at 0, 1, and you also have a point at 1, 3. And then it's going to do something like that. Okay. So that is, what happened there? Y equals 3 exponent x. And let's do 5x. So for example, 5 squared would be 25. So at 2, it's going to be 25. That's not helpful. And at 1, it's going to be 5. So 1, 2, 3, 4, 5. And then 0, it's also at 1. And then it's going to follow a similar pattern. So it's just a little steeper. So that's y equals 5 exponent x. So what do we notice about all this stuff? Well, let's write a little summary. All three graphs have the same domain, range, and y-intercept, as well as the same horizontal asymptote. All three rise from left to right, and this is called exponential growth. As the base of the function increases, the slope becomes steeper quicker. Sure, that's poor grammar, but there you go. All right, so, one more example. If we had, y is equal to 5 to the 9, like y is equal to 9 to the x, well, that's just going to go up even quicker. And even a bigger base number, that's going to go up even quicker. Let's graph y equals half x and y equals 1/5 x. All right, so again, a little table of values to help you sort out what you're doing, and pause the video and then hit play, and then you should find something similar to what I'm going to graph here. All right, so if you pause the video and now you've clicked play, yours should look something similar to this. The y equals 1/2 x is there, and the y equals 1/5 x is there. So what do we notice about these two graphs? Well, all the graphs have the same domain, the same range, the same y-intercept, and same horizontal asymptote. This is called exponential decay. And exponential functions with a base of between 0 and 1 will fall from left to right. It's going to do something like that. And one more point. As the base of the graph gets smaller, the graph falls quicker. Again, poor grammar, but it's math class. So what does that mean? Well, if you had like another one, like y is equal to 1/10 x, well, that's going to fall extremely quickly, okay? So graph these two functions on the grid provided, and let's see what happens here. So y is equal to 2 and 3x, y is equal, 2 multiplied by 3 exponent x, and y is equal to 5 multiplied by 2 with an exponent of x. So let's check these out. The first one, y is equal to 2 exponent x, is going to give you something in the range of like 355, somewhere up there. And then it's going to be 2 and like 20-ish, and 1 and 5. And it's going to go through 2. It's doing something like this. It's pretty poor graphing, but there you go. So that is y is equal to 2, 3x. And now let's graph the other one. And it's going to go through like 4 and 80. And it goes through 3 and 40. And then like 2 and 20 something. 10, and then it's going to actually go through 5. That's y is equal to 5 to x. So what do you notice about the y-intercept? If an exponential function is in the form y is equal to a multiplied by b to the x, the y-intercept is equivalent to the value of a. And why is that? Well, if you're to plug in 0 for x, that means that this part, the b0, becomes 1. And so you're just multiplying a multiplied by 1. So that's how you get the a value. So here's a bit of a summary. If an exponential function is in the form y is equal to a bx, where a is a constant and b is greater than 0, when b is greater than 1, the function is increasing and represents exponential growth. That part's important. That was the first example. It's going to do this. Okay? And when b is in between 0 and 1, that was like the fractional stuff, it's going to be decay. So it's doing something like that, but more drastic. The domain for both is x ER. The range for both is y is greater than 0 and y ER. The y-intercept is the a value, oops, don't need squiggly lines, is equal to a. There's no x-intercept. The asymptote is y equals 0, and I should say a horizontal asymptote y equals 0. And the end behavior, this part's new information, it starts in quadrant 2 and ends in quadrant 1. Whoops. So if you remember, your quadrants are 1, 2, 3, and 4. So they're starting in quadrant 2, and they're ending in quadrant 1. And either way, you know, if it's exponential growth or decay, okay, they're both starting in 2, going to 1.